my god. What was that? What was To all my friends out there who say science is hard, I would like to say to you, it is not. I'm sorry. Science is just a lemonade. I'm pretty sure that this one is perfect. Yeah, as I guessed, it was, because I measured everything. Science strives to give us the one last perfect one. So, SiMpLE Chutney proudly presents you the scientific lemonade. Egregium, that's Latin. Universally, it's known as the remarkable theorem. It's called remarkable because it does not consider about the three-dimensional Euclidean space that envelops the object under observation, and hence applicable to Earth and many other celestial objects. The remarkable theorem is that if the curved surface is developed upon any other surface on Earth or outside Earth, the measure of curvature at all the points, hope you can see those points here, 1, 2, 3, all the points must be the same. That's what Carl Friedrich Gauss said. Now this is going to be an illustration to find out the curvature of surfaces. Now this is a flat map which is circular in shape, but the curvature is going to be 0 because it is totally flat. And now it's a tennis ball which is a sphere, and at every point the ball is curved, and hence we can conclude that the curvature of this surface would be positive. Now, according to Carl Friedrich Gauss, the curvature of an object is the same at all points on the object. Now let's take a point on this flat map. Take 2 dimensions. I'm gonna draw a straight line, that's 1 dimension, and a perpendicular line, that's another dimension. I'm gonna retrace the path so as to make it clearly visible to you. The curvature is 0 here, and the curvature of the perpendicular line is also 0, and hence at that point the curvature would be 0 multiplied by 0, which is equal to 0, and that's how we have to find the curvature at a point in an object. Now let's do the same for the tennis ball. Take a point, draw 2 dimensions. Number 1, the curvature would be positive because as we can trace, we can find that the curvature is positive. That is, it is curved. The same way I just drew another and found the curvature to be positive, and positive multiplied by positive, which gives us positive. Hence the curvature is definitely positive for this tennis ball. Scientists try to convert the Earth into a circular map. Alice, scientists say that the curvature of a circle is 0, whereas for a tennis ball it is positive. Now that's illustration number 2. I'm gonna cover this tennis ball with a world map in order to make it globe. Yeah, that's pretty much imperfect. Yes, it is imperfect because of the distortions, the cramps. I guess you can see all those cramps round and round. I think you can see those distortions, the irregular surface over the sphere. I think I'm gonna sellotape it like that. That is, I'm gonna rule out the distance, the area, the height which is taken over by those distortions, because the curvature should be the same at all points. That's what I'm doing. I'm sellotaping because each and every distortion is a disturbance to the shape of the earth. So, which means that in a world map, the upper part of the earth must be enlarged and the middle part must be shrinked and the lower part must be enlarged again to get a world map which is flat. And you can see that the earth is perfectly round. It's actually a geoid. All the points on the earth, the curvature is the same. So this is the remarkable theory of Carl Friedrich Gauss, which proves that our world map is absolutely wrong.